In this ever-changing digital landscape, as enterprises strive for cybersecurity excellence, they face ongoing challenges, and the likelihood and severity of cyber attacks is also increasing due to our growing dependence on new information technology platforms and interconnected devices and systems. Thank you for joining this session on optimizing security operations using AWS Systems Manager. I'm Praveen Bhatt, an Enterprise Solutions Architect at AWS based out of Melbourne. In this session, I'll show you how AWS Systems Manager can help improve your security operations by enforcing patch baselines and securing remote access across all of your AWS accounts, regions, and non-AWS resources. Let's have a look at what we'll be covering in this session. To begin with, we will have a look at the current landscape of cybercrime and the impact it has on organizations. We will then talk about a fictitious company, Globex Corporation, and some of the challenges they're facing in their security operations. With a problem statement defined, we will discuss what AWS Systems Manager is. Then, we will see how Patch Manager and Session Manager, which are two features in Systems Manager that can help Globex and their security team with some demos. A report from McAfee and Center for Strategic and International Studies titled The Hidden Cost of Cybercrime in 2020 concluded that global losses from cybercrime was over $1 trillion, a more than 50% increase from 2018. The theft of intellectual property and monetary assets is damaging, but some of the most overlooked costs of cybercrime come from the damage to company performance. The report revealed that apart from the financial costs, organizations felt other negative effects on their business after a cyber incident. Average cost from the longest amount of downtime in 2019 was roughly $762,000, while the range generally hovered around $100,000 to $500,000 due to system downtime. As a result of system downtime, organizations lost on average 9 working hours a week, leading to reduced efficiency. The average interruption to operations was 18 hours. It took an average of 19 hours for most organizations to move from the discovery of an incident to remediation. The cost of rehabilitating the external image of the brand, working with outside consultancies to mitigate brand damage, or hiring new employees to prevent against future incidents were all part of the cost of cybercrime. If we were to filter out many such reports and studies, the two common items that we find at the top of any exploitation list are unpatched vulnerabilities and exposed remote desktop protocol, or RDP. The latter especially seeing a huge surge with remote working conditions. So let's talk about Globex Corporation, a fictitious company that we will be using for a session today. Globex, in over 40 years, has grown into a multi-billion-dollar conglomerate spanning across multiple industry verticals. In the last 4 years, they've started moving to AWS, but still have a presence on premises, facing new challenges with managing hybrid environments. Alice, the Chief Information Security Officer, leads a strong but small team of security professionals to protect the organization's IT landscape. The organization recently experienced a major security breach, with multiple critical IT systems being compromised, which led to outages and some serious reputational damage, causing a big defection in their customer base. The organization is currently undergoing a root cause analysis and an audit by a third party. The initial findings point to 2 key reasons for this event. Firstly, patching levels on most compute instances were inconsistent, with a few that had 2 to 3-year-old vulnerabilities. Secondly, a compromised jump box, which is primarily being used by developers and operational staff to access remote instances and to establish tunnels to access remote applications. This instance appeared to have limited controls, which allowed the bad actors to enter into the Globex systems. The CIO has tasked the security operations team to immediately address the key findings of the audit while ensuring the costs are kept in check. Globex, along with Alice, have found themselves in a situation no different to what we've seen numerous other organizations go through. Managing hybrid environments is complex and costly when using traditional toolset. So now that we have some context on the problem, let's have a look at what Alice and her team is up against. They need to standardize patch management with a single solution across their IT systems, which are running both on AWS and on-premises infrastructure. They need to implement organization-wide visibility to ensure their systems are compliant. A solution that provides secure remote access to their machines and allows developers to remotely access tools and applications securely and privately. All of this without having to deploy multiple products and dealing with licensing costs and complexity. So the goal of this session is to show you how we can help Alice and her team in delivering a solution for these 4 challenges using AWS Systems Manager. So what is AWS Systems Manager? I like to think of Systems Manager as the operations cockpit to centrally manage hybrid cloud resources at any scale. It gives you visibility and control of your infrastructure on AWS. It provides a unified user interface so you can view operational data from multiple AWS services and allows you to automate operational tasks across your AWS resources. So why use Systems Manager? AWS Systems Manager helps you quickly view operational data for groups of resources, so you can quickly identify any issues that might impact applications that use those resources. It also enables you to automate operational tasks to help make your teams more efficient. AWS Systems Manager also helps you easily understand and control the current state of your resource groups. With Systems Manager, you can view detailed system configurations, operating system patch levels, software installations, application configurations, and other details about your environment. With AWS Systems Manager, you can manage servers running on AWS and in your on-premises data center through a single interface. It securely communicates with a lightweight agent installed on your servers to execute management tasks. And lastly, it helps maintain security and compliance by scanning your instances against your patch, configuration, and custom policies. You can define patch baselines, maintain up-to-date antivirus definitions, and enforce firewall policies. Systems Manager has numerous features built into it in the 4 categories as shown here. But for this session, I'll be focusing on Patch Manager and Session Manager. As the name suggests, Patch Manager helps you automate the process of patching both your operating systems and applications. Patch Manager uses patch baselines, which include rules for auto-approving patches within days of their release, as well as a list of approved and rejected patches. You can install patches on a regular basis by scheduling patching to run as a Systems Manager maintenance window task. You also have the option to install patches individually or to a large group of instances by using Amazon EC2 tags. Patch Manager supports a variety of operating systems, including Windows and various flavors of Linux. It integrates with AWS Identity and Access Management, or IAM, AWS CloudTrail, and Amazon CloudWatch events to provide a secure patching experience that includes event notifications and the ability to audit usage. So let's take a look at what we'll be covering off in our demo for Patch Manager. We have a simple 2-tier application with 3 web servers on Linux and 3 database servers running on Windows, with a tag predefined for patch group. These servers have Systems Manager agent pre-installed on them, hence configured for Systems Manager. A managed instance is any machine configured for AWS Systems Manager. This can be EC2 instances, virtual machines in your hybrid environment, or running on premises. We will be defining what patches will be applied on the instances using a patch baseline. Then, we will be creating patch groups to associate instances with a specific patch baseline. Patch groups help ensure that you're deploying the appropriate patches based on the associated patch baseline rules to the correct set of instances. Based on the maintenance window, Patch Manager will be triggered to apply the relevant patch baselines on each of these instances. Under the hood, Patch Manager uses the run command to run the AWS-provided AWS Run Patch Baseline document, which can apply a patch baseline across both Windows and Linux platforms. Once the patches have been applied, the results will be aggregated using Systems Manager's compliance capability. You can use compliance to scan your fleet of managed instances for patch compliance and configuration inconsistencies. You can collect and aggregate data from multiple AWS accounts and regions and then drill down into specific resources that aren't compliant. Now it's time to jump into the demo to see it in action. I'll first start off with AWS Systems Manager Fleet Manager. As you can see, I have 3 web and 3 database servers running on Linux and Windows respectively. If you recall, I mentioned that we have 2 patch groups in this demo, ProdWeb and ProdDB. Let's check the instance tags to ensure they've been defined correctly. As expected, we have 3 instances with the ProdDB tag. Let us see their current patch state by navigating to compliance. Filtering by patch group shows that all our instances are currently non-compliant. You can filter by resources or rules. The latter shows us exactly how many of the rules the instance is non-compliant with. Clicking on the rules, we can see which patches are missing. Let's click on one of these instances to find out more about the missing patches. I'll filter based on the missing rules. Perfect, now I know which patches are missing on my instance, so time to fix them. Let's close this and navigate back to Patch Manager. As you can see, you either have the option to choose one of the predefined or default baselines provided by AWS or create your own. Please note that you cannot edit any of the default patch baselines. However, you can make your own custom baseline to be the default baseline. I have pre-created 2 baselines for the purpose of this demo, one for Linux and another for Windows. Let's go through the configuration for the Windows baseline. As you can see, I've given it a name and a description and then chosen the operating system, in this case, Windows. Moving on, I have the option to define the approval rules at the operating system and application level. In this demo, I'm going to focus on the operating system. I have selected all the Windows products with critical and important severity for critical and security updates. I've also defined the auto approval to apply those patches after 15 days of the release. If any of the instances were to deviate from this rule, then you can specify the severity for reporting and monitoring. You also have the option to whitelist and blacklist individual patches centrally, and this is quite useful for organizations that occasionally want the ability to reject individual patches. The other patch baseline is quite similar, but focused on the Linux operating system. Now that we have the patch baselines defined, let's ensure that they've been associated with their respective patch groups. The key thing to note here is that your patch group should match your tags defined in your instances. Great. Next, let's configure the execution of the patching operation. For instance selection, you can either do it by tags, manually select the instances, or use patch groups. We'll be selecting both the patch groups. Moving on, for the patching schedule, you have the option to define the maintenance window where you can control various attributes like frequency, concurrency, and error threshold. However, for this demo, I'm going to skip scheduling and patch the instances right away. For the patching operation, you have 2 options, scan and install, which is the default option, or scan only. With scan only, each target instance is scanned and a list of missing patches generated. And with scan and install, each of the target instances are scanned and the missing patches are applied from the list of approved patch baselines As we are aware of the missing patches, let's go ahead with the scan and install option. As you can see in the banner, Patch Manager invokes run command to apply the patch baseline. Let's have a look at what's happening behind the scenes. If we jump to run command, we can see a command currently being executed. Let's click on the ID to dive deeper. We can see that AWS Run Patch Baseline document is being run on the 6 instances with the scan and install operation. If you want to see further details, including the output of this document, then just click on one of the individual instances in the list above. Depending on your fleet size, this operation normally could take a few minutes to complete. Now that the run command is completed, let's head back to compliance to check the latest patching status. As you can see, all the missing patches have been applied and our web and database servers are now compliant again. So you've just seen how we can use Systems Manager's intrinsic capabilities to manage and patch your instances across various platforms. A huge step forward to help you be compliant and secure. But how can Globex use Patch Manager to address their challenges with regards to patching and compliance? The demo was developed using a foundational architecture. However, the security operations team at Globex can leverage Patch Manager and, using the same principles that we discussed in the demo, extend the solution for a multi-account and multi-region setup in AWS, whilst managing the patching for their on-premises virtual machines as well. Regardless of the number of instances, Systems Manager will scale to manage patching for thousands of instances using the same underlying document with the help of run command. Simply put, Globex can save hundreds of engineer hours every year by fully automating patch management. They can also run other documents to deliver functionality like removing instances from an autoscaling group, or taking snapshots before an EC2 instance is terminated, or it could be as simple as running basic tests post-patching. Systems Manager also supports integration with IT service management tools such as ServiceNow. This, along with Systems Manager compliance, can give Globex organization-wide visibility, allowing the team to improve their security and compliance posture while saving cost. With the first two challenges being addressed using Patch Manager, let's move on to our next set of challenges. Session Manager is a fully managed AWS Systems Manager capability that lets you manage your EC2 instances, on-premises instances, and virtual machines through an interactive, one-click, browser-based shell or through the AWS command line interface. AWS Systems Manager provides a browser-based interactive shell and command line interface for managing Windows and Linux EC2 instances without the need to open inbound ports, manage SSH keys, or use Bastion hosts. Administrators can grant and revoke access to instances through a central location by using AWS IAM policies. This allows you to control which users can access each instance, including the option to provide root access to specified users. Once access is provided, you can audit which user accessed an instance and log each command to Amazon S3 or Amazon CloudWatch logs using AWS CloudTrail. There are various ways to start a remote session using Session Manager. But in this session, we will be using the Systems Manager console and the port forwarding option. Let's jump into the scenario I'll be covering off in the demo. For this demo, I'll show you how to securely access EC2 instances using Session Manager. And since I've used Windows, I'll be accessing them over Remote Desktop Protocol or RDP. In this setup, we have two instances. One deployed in a public subnet, which is accessible over the internet, and another in a private subnet, which isn't. The security group for the public instance allows for remote desktop protocol access from anywhere, while the private instance allows for HTTPS connections from the two subnets in our VPC. We will be covering in detail why we set this rule later on. I'll first start off with accessing an instance in the public subnet using RDP, and then show you how we can use Session Manager to establish an interactive shell with the instance in the private subnet which has no open ports, thus helping improve the security of the remote instance by limiting its attack surface. Since this instance is not accessible over the internet, we will be using VPC endpoints. A VPC endpoint enables private connections between your VPC and supported AWS services, and VPC endpoint services powered by AWS Private Link. And finally, we will see how you can configure port forwarding using Session Manager. Port forwarding allows you to forward traffic between your machines to open ports on your instance. For this scenario, I'll be accessing MySQL databases running on the remote private instance with no inbound ports open. Now that we understand the scenario, let's jump into the demo. Just to set the context for this demo, typical ways of accessing an instance is either using a Bastion host that acts like a jump box to remotely access your instance, or if the instance is accessible over the internet, then establishing a session directly. Now, on the console, we'll navigate to the EC2 service. As you can see, I have two instances that are currently running. Let's connect to the public instance by clicking on Connect. I'll then download the RDP shortcut file that will allow me to access the instance using the default administrator credentials. I'll then key in the username administrator along with its password and log into the remote instance. Next, let's verify our credentials to confirm the session was established using the administrator user. Now that we've seen one of the typical ways of connecting to an instance, let's go back to the console and terminate this session. As you can see, there are a few potential security concerns with this approach. Any user with a valid account on the instance and access to the AWS console can sign in using this method. And in addition, the RDP port must be open to establish the session, which could expose the instance to outside attacks that leverage potential vulnerabilities in the remote desktop protocol. How about we look at a more secure method of connecting to the instance? Instead of connecting using RDP, you can use Session Manager. And as I mentioned earlier, with Session Manager, you can securely connect to your remote instances without managing any Bastion hosts, open RDP ports, or manage secure shell or SSH keys. So let's go ahead and make sure that the private instance has no RDP ports to begin with. Next, let's confirm that we can no longer use RDP to connect to the instance. As expected, the warning highlights that we cannot connect to this instance using a standalone RDP connection. One of the prerequisites for Session Manager is for the instance to have an IAM role associated with it that allows for it to be managed by AWS Systems Manager agent. This role uses the Amazon Managed SSM Managed Instance core policy that provides it all the necessary permissions. Now, since the private instance has no internet connectivity, we will need to create VPC endpoints to Systems Manager and EC2 services. So let's navigate to the VPC dashboard for the VPC endpoints. Now, as you can see, I've created 3 VPC endpoints to allow Systems Manager to connect with our private instance. Now, you may recollect that we opened up the HTTPS port from the 2 subnets for this instance. This allows for Systems Manager to connect securely with the SSM agent running in the instance without any internet access via the endpoints that have been deployed in the subnet. Now, I mentioned earlier that we have various ways of connecting to a remote instance using Session Manager. But in this instance, I'll be setting up connectivity via the Systems Manager console. So let's quickly navigate to the Systems Manager dashboard and open Session Manager. Now that we have all the prerequisites, let's start a console session to the private instance. There you go. We've securely connected to a private instance which has no RDP port opened up. Let's quickly check which user was used to establish the session. This SSM user is the default operating system user when a session manager session is started. Now that we've seen how we can securely connect to a private instance which had no RDP ports opened up, let's move to the next part of this demo. We will be establishing a port forwarding session to access our remote MySQL databases running in the private instance from our local machine. To begin with, we will need to execute a few commands to create a new standard user account called demo user on the instance, which we will be using for port forwarding. We will then assign this user to the remote desktop users group so they can connect using RDP. So for now, let's terminate this session, and we will now navigate to the IAM dashboard. In here, let's review the IAM user and policy that I have created for the demo user account. Notice that a custom inline policy has been attached directly to this user. Let's have a look at the policy. Here, you can see all the necessary permissions required to use port forwarding to connect to the private instance in Session Manager. In order to establish the port forwarding connection, I'll need two components installed on my local machine, AWS CLI and Session Manager plugin, which is required to start and end sessions using AWS CLI. So for now, let's switch to my IDE. I've already configured AWS CLI with the demo user that we saw earlier in IAM and the Session Manager plugin. Let's make sure they're in place by checking their versions. Perfect. Now to set the scene, let's have a look at the database connection that I had already configured and make sure that we cannot access our remote database. Now let's start a port forwarding session using the AWS CLI. A few things to note here. The instance which we want to connect to has been specified as the target using the AWS Start Port Forwarding document. For the parameters, I'll be passing an unused local port 12345, which is mapped to the remote port 3306 used by the remote MySQL engine. Now that we have the port forwarding session established, let's try to reconnect to our remote database. And there you go. I can now securely access all my remote databases hosted on the private instance using port forwarding without actually having the application port opened up on the instance. Just to confirm, let's terminate the port forwarding session and see if we're able to connect to our remote databases. As you would expect, the connection fails. The remaining challenges we had were around securing remote access and allowing developers to remotely access applications securely using port forwarding. All of this without the use of any jump boxes or bastion hosts. As seen in the demo, these can be addressed using Session Manager. Now let's take a look at how GlobeX can incorporate Session Manager in their IT landscape. Session Manager provides a robust solution for GlobeX's development and support resources to access remote instances securely. The security operations team will no longer have to deal with the undifferentiated heavy lifting of managing jump boxes. This could help reduce the footprint of bastion hosts, saving numerous instances from being provisioned and managed. More importantly, they can control access centrally using AWS IAM with identities being controlled using their central identity provider like Active Directory. With all the commands being logged, Alice and her team can now gain insights on every event by aggregating and analyzing the logs into SIEM tools like Splunk or Sumo Logic. Session Manager not only helps GlobeX enhance their security posture with respect to remote access, but also helps improve the developer productivity in a secure fashion. So we've just seen how we can use AWS Systems Manager to help solve GlobeX's challenges, which are no different to what many of your teams might be facing today. Systems Manager can become your organization's security operations cockpit to help improve your security and compliance posture by leveraging existing personnel, ridding them of the undifferentiated heavy lifting around patching and securing remote access, whilst improving your team's productivity and morale. Here are some links to the artifacts that were mentioned in this session for your reference. You joined AWS Summit to learn, and you can keep learning beyond the summit with resources from AWS training and certification for security. According to Global Knowledge, IT decision makers report having the most difficult time finding qualified cybersecurity talent. So training has never been more important. We offer more than 25 digital and classroom courses for you and your teams around security, identity, and compliance. You can also showcase your expertise by pursuing the AWS Certified Security Specialty Certification. If you enjoyed this video, don't forget to give your feedback. Thank you so much.